All right, we're going to do more area of regular polygons. Last week we learned that the area of a regular polygon is 1/2 the apothem times perimeter. When you did this, your homework gave you the apothem every time and one side, and you just multiplied to find the perimeter. Today, you're going to have to find the apothem because it won't necessarily tell you what the apothem is. Or it might tell you the apothem, but it doesn't tell you the length of one of the sides, and you're going to have to find it. All right, this tells you that it's a regular polygon. You know that this is what kind of a triangle right now?
Equilateral.
It's an equilateral. You have a formula for an equilateral triangle. What is the formula for the equilateral triangle?
A equals 1/4 square root 3s2.
Very good.
Square root.
And you know what the side is. So if we go 1/4 square root 3, what is 14 square root 3 squared? What is the
Wait.
You'll need it exact. So careful what your calculator might do.
Squared?
Yes. 14 square root 3 squared. What is that?
Oh.
14 squared? 196.
196 is 14 squared. And then you multiply it just by, and the square root of 3 squared just takes off the square root. So it's just 196 times 3. Now, you could just don't write anything down, and just forget the square root of 3 for a minute, and then multiply by 1/4 or divide by 4.
Wait, what's happening?
Okay,
I
so
was thinking.
Sorry, what'd you get?
let's reel it in. I'm sorry, let's go back. Here we go. So what did you guys get when you did 14 square root 3 squared?
I got 42.
42 can't work.
I kind of figured
So
it out.
do I need to do 14 squared and then that times 3?
Yes, very
Okay,
good.
580.
I got 580.
Okay, now don't write anything down. I'm not suggesting that you write. You got that now, Amy? Do you understand how we got that? Okay. Why did I just plain old 3? Why not square root 3?
Because the square root cancels it out.
Because the square roots cancels the square cancels it out. Very good. Okay, so this part right here is 588. We don't multiply by the square root of 3 because it wants it to leave the radical there. It doesn't want you to multiply the radical out. But we do need to divide by 4 now.
Leave the radical?
It says up here in the instructions to leave your answer in simplest form, meaning simplest radical form, and that means that you're not going to get a decimal.
So now we're going to plug in 588 for s, right?
No, we're going to put 588 and divide by 4 for the 1/4. And if you get a fraction, you need to have your calculator turn it back into a fraction, not as a decimal.
147.
I heard 147. Is that true?
That's what I got. That's what I got. Yeah, that's what I got.
Okay, so you got 147. What do I do with the square root 3?
Times.
I just tack it.
147 square root 3.
Yes, just tack it on at the end, and it is being multiplied. Very good. All right, so we're going to number 3 now. All right, number 3 says, find the area of a regular polygon. Leave your answer in simplest form. It does not give you an apothem. Okay? I'm going to tell you a trick.
We can figure out
with
the interior angles, can't we?
We can figure out some of the interior angles. So if I come in here and I put it invisible, it's invisible now, a dot in the center. So give yourself a dot in the center and give yourself a triangle.
What?
How many degrees is this triangle right there?
14.
This length is 14 right there. But what's that angle right there? How many could I draw in here? How many triangles could I draw in there?
6. Oh, 6.
So since it's regular, how much is it all the way around? 360. So how much is just one of them then?
360 divided by 6.
Okay, so 360 divided by 6. What is that?
Oh. 120.
No.
60.
Yes. 60 degrees. Okay? We know that these two are equal because it's an equilateral triangle, because these two are equal. There's that theorem that says that. So what do those down there have to be?
You can just do
What do these angles have to be right here?
60.
60. So what kind of a triangle is this?
Equilateral.
How many equilaterals do we have?
6.
6 of them. So if I could find the area of just one of them and then multiply by 6, I would have the entire equilateral, hexagon, correct?
Correct.
What is the formula for an equilateral triangle?
A equals 1 over 4 square root 3 s squared.
And I'm going to tack on times 6 at the end. That work?
That'll work.
Okay. So where does the 14 go in all of this?
Sine
Right.
squared.
Yeah.
Okay. So I'm going to have 1/4 square root 3, 14 squared times 6. I would suggest don't do the square root 3 in your calculator. Do your 1/4, your 14 squared, and your 6. Put them all in there. Hit enter, and then we'll see what you got.
1,176.
1,176. Do I have somebody who confirms that?
No.
14 squared times 6.
Time, but then.
Oh, do your 1/4. Do your 1/4 next.
Oh, I didn't do the 1/4.
Wait a minute.
294.
What I got.
Okay, and then what do I do with the square root 3?
It's 294 square root 3.
Tack it on at the end, yes, because we multiply it. Make sure we got it. I'm going to pause here.
I keep writing the wrong number.
A hexagon, a regular hexagon, is just 6 equilateral triangles. There is another way to do this. I'm going to show you, but I'm not going to have you write anything down for it, because you already wrote something down for it. We could have realized that, yes, this is a 60-degree triangle. And this one is half that. So we have a 30, 60, 90 triangle. This is 14 right there. This is 7. So what's the hypotenuse?
The 14? 14.
This was the 14. That's the 2A. This is the A. So what does this one have to be? What does that apothem there have to be?
Oh. 14 square root.
No,
7 square root 3.
7 square root 3. So you could do 1/2 the apothem times the perimeter using the apothem as the 7 square root 3 and your 14 times your 6. I think that the equilateral triangle thing that we did just a minute ago is easier.
Yeah,
Okay? Okay.
I agree.
That's why I didn't have you write it down, because I thought you probably would agree. Okay? All right. Let's move on. Number 5 says, find the area of a regular polygon. Leave your answer in simplest form.
Question?
Is this the dot or the side?
All right, so I'm going to have you
You got
connect
2 triangles.
this here. Okay?
Yeah, this one.
Connect the dot in the center to a corner over there. It doesn't really matter which corner, except for the whole one. It would be good. All right, what is this angle right here, and how do I find it? How many of these triangles could I have drawn?
4.
4?
Yes, and how much is all the way around?
360?
260.
360. So what do I do to find just one of them?
360 divided by 4.
360 divided by 4.
90?
I heard 90.
Yeah.
Okay. So, if that's 90, and these are equal because these are both radii, excuse me. So, what do those ones down there have to be?
90.
90, 90, 90 would be over 180, and we couldn't have that.
Oh.
So they all add up to 180, correct?
45.
How did you figure that out to help everybody else? How did you figure that out?
45 plus 45 is 90, right?
Yeah.
Yes.
90 plus 90 is 180.
'Cause they're-
So I took 180 and I knew that there was going to be 90 there. And so I'm like, okay, that's half. So we have to split it in half again.
Right. So they all add up to 180, correct?
And if you just think about 45, 45, 90 triangle.
Yes. Yeah.
After I figured it out the
Right.
hard way.
So they all add up to 180. If I subtract this 90 right here, I've got 90 left. And these two have to be split into 2 pieces, so it's got to be 45, 45, right? Okay, so this is a 45, 45, 90 triangle. There is not a special formula for a 45, 45, 90 triangle for the area, but if we know that's 14.2 and that's 14.2,
14 square root 2.
should be 14 square root 2, maybe we could find
gonna be 14.
The hypotenuse.
Yeah. It's gonna be. Hold up.
What do we do to find it?
56.
How do you know that? What did you do?
I multiplied it by the square root.
Okay, so we know for our little special formula that's, if this is A, this is A, this is A square root 2. So whatever this side is, I multiply by the square root of 2. So that means I take 14 square root 2 and I multiply it by square root 2 to get this side, right? That's the hypotenuse of that. What do I do with those 2 square root 2 square root 2's? What happened to them?
It becomes a.
They cancel out and just become plain old 2. And 14 times 2 is?
28. Yeah.
28. All right.
I did that wrong.
How does that help us find the area of that square?
We now have a side.
We now have a side. Do you know
We
the
just-
formula for the area of a square?
Yeah.
I don't remember it.
It's the same as a rectangle.
Yeah, same as rectangle, and the rectangle is
Length times width.
length times width, or base times height, depending on how you say it. All right. So, what do we do then?
28 squared.
28 times 28, or 28 squared.
I got 784.
Someone verify that.
Yeah.
What did you get? 784.
All right. So let's go to number 7. This time we can't use our 1/4 square root 3s squared because they don't give us the side. They give us the radius. We could try to find the side, though, to use that formula. Or we could just find the apothem and then that side and use apothem and perimeter. So I want you to know something, that when you find the apothem, when you find this part of the side, you have just double it to get the other part. And 20 is the radius. I'm going to make sure we understand that 20 is this piece here. Okay? How much is that angle right there? How much is the whole angle?
Oh, the whole angle is 60.
How do you know that?
Because it's a regular polygon.
It's always regular. This is a
So that
regular.
angle needs to be
And it has to be
30.
60, 60, 60 is the only thing.
So the angle has to be 30.
So this angle has to be 30 because it does split it in half. All right. This one is 90 right here. This is a what kind of a triangle in there, the little one?
30, 60, 90.
A 30, 60, 90. Okay. I'm going to get rid of this piece. Oops, oh my goodness. It's huge. All right, so how much is this one over here, the yellow one I just put up there? This one right here.
Oh.
No, the hypotenuse is 20.
Yeah, so it's going to be.
The opposite, the
Use
30.
the sine, cosine, tangent 90.
You could use sine, cosine, and tangent, but you won't have to if you know your 30, 60, 90 triangles.
We take this.
Let's go. Let's
it's
just
gonna be
review
10.
real quick over
It's gonna be
here.
10.
Your 30, 60, 90. If this is, I'm going to actually draw it so it looks like that one. If this is the 30, which one's the A, which one's the B? I mean, A, 2A, and A squared 3.
The one that's sticking straight up is A.
This is A. This is 2A.
Isn't
And this is A squared 3, right?
that-
Okay, so how big is this yellow one that I drew a minute ago? This yellow one. It was yellow, but now I've made it purple. This one.
10.
It's 10. Okay, so it's 10. This is why you have to know your 30, 60, 90 triangles. Then how much is this piece right there? Right there.
10 times square root 3.
Yes, 10 times square root 3. How long's the whole thing? Right here.
20 square root 3.
20 square root 3. Okay. Let's make sure we got this. You have a choice now. You can use the 1/2 the apothem times the perimeter, or you can use the 1/4 square root 3s squared. You're going to get the same answer if you use both of them. And it doesn't matter which one you choose.
Can you say that again?
You can use the 1/2 the apothem times the perimeter formula, or we can use the since this is an equilateral triangle, we can use the 1/4 square root 3s squared. You choose. And I don't think either one of them is going to be easier or hard. Since nobody's picking, since we already did the 1/4 square root 3s squared, let's do the 1/2 apothegm times perimeter, since we don't have experience with that one. So area equals 1/2 the apothegm times the perimeter. We just have the 1/2. By the way, the apothegm is the one that comes from the center down, so we know it's how much? 10, okay? And the perimeter, we know one side's 20 square root 3, so if we go all the way around, there's
20 square root 3 times 3.
So what is 20 times 3? 60. All right, so that's our perimeter. It says to leave them in simplest form, so we need to keep that square root 3 out. So we just need to multiply 1/2 and 10 and 60. 300, is that, somebody confirmed it, I heard? Okay. 300 square root 3. Polygon, very good. This is a polygon. This is a regular hexagon. It's given us the apothegm, okay? Right now we have the apothegm. We could use the area is 1/2 the apothegm times the perimeter. What are we missing in there that we don't have? That's correct. So we don't have the perimeter. That means we don't have, and we don't even have the length here to multiply by 6, correct? Mm-hmm. But if I drew a triangle here, do you remember the last time we did an equilateral, a equilateral hexagon or a regular hexagon? What kind of shape was that there that I just drew?
Triangle.
It's a triangle. What kind of triangle? What are the angle measures? What is this? It's what?
Equilateral.
It was an equilateral triangle. That's right. So if this right here is 60, we now know that's a 90, and this is 30 over here, right? We are looking for this.
You did it an easier way than I did.
We're doing this orange part here, or the yellow part there. And I don't like the way they put that 5 square root 3. I'm going to re-put it in here. It's really on top of this apothegm. It's hard for me to tell. Okay, so if that is the 5 square root 3, what is my yellow part, or the opposite the 30?
Opposite the 30? 5?
Yeah. How do we know? Let's draw this down here. I'm going to draw it similar. I've got the hypotenuse. Here's the 30. Which one's A always on a 30, 60, 90 triangle?
One opposite the 30.
30. So if this is
one,
A,
yeah.
this one's the 2A, which we don't really need right now. And this is the A square root 3. So if you knew, actually we could find it. If this, so if this was 5, then that's 10, right?
Yeah.
This has already got the square root 3 tacked on. 5 square root 3, that's nice. So we just take the A part, which is the 5, and stick it over there. So we know that this is 5. Makes this 10. How long is this whole piece,
10.
the whole yellow part?
10.
Because I double it. It's 5 and 5, right?
And because it's an equalateral triangle, the sides are going to be the same.
Yeah, so this whole thing's going to be 10. All the way around.
No, I mean, like, when you found the one side of the
Yes,
equilateral
you're right.
triangle.
Since this one over here was 10, whoops, this one over here is 10, then this whole side over here was 10. I agree. Yes. Yes. Okay. Here we go. We have everything we need to know. 1/2. Apothegms, how much?
10.
5 square root 3.
Yes, the apothegm is this part right here.
That's right.
5 square root 3. P, or 10, is one of the sides, but P stands for perimeter.
So you need 100.
No, there's 6 of those sides.
Oh,
Perimeter means how many does it take to go all the way around? There you go, 60. Very good. And now we take the 60 times the 5 times the half.
150.
I agree. And tack that square root 3 on top.
What? How'd you get 150?
I
5
took,
times 60 divided by 2.
Yeah.
in my head I took half of 60 is 30, and 30 times 5 I knew was 150. What you doing?
Yeah.
Okay. All right, you're going to have to use your 30, 60, 90 triangle if you need keep a drawing of your 30, 60, 90 triangles at the top of your paper and a 45, 45, 90 triangles at the top of your paper. That will help. Let's do number 11. 11 is very similar to the one we just did. They're giving us the apothem. 1/2 the apothems times perimeter is what I would be using. What they gave us the apothem, but they didn't give us the what?
Side.
They didn't give us the side, so we can find the perimeter, right? What kind of triangle did we say this was? It's an equilateral right here. That's right. I'm going to take half of it here. If this one was 60, this is 30. If this side is 8, how do we find the little one?
8 divided by square root 3.
8 divided by square root 3, huh?
Is that right?
I agree.
That's fine.
I'm not gonna do anything with it just yet. I'm not gonna rationalize it just yet. Just yet. We can do it in a minute.
4.6.
And we're gonna have to leave it in symbols to radical, so you're gonna have to leave
Can't
it.
do decimals.
Oh.
You can't do decimals.
Wait,
Ooh.
what?
How long's the whole thing? If that little piece is 8 square root 3, how long's the whole thing? 16. So I'm going to write it over here because it's the same as this one. 16 square root 3 is this length of a side. All right, here we go. Not 16 times square root 3. 16 over square root 3. My bad. 1/2 apothem times perimeter.
Oh.
Wait, that's a side.
Yeah.
Okay.
Apothem is...
Yeah, really though.
Apothem's how much?
8.
8. Now we need to do that perimeter. We're going to have to multiply by 6, but we're going to have to rationalize this 16 square root 3 thing here. We're going to have to. I can't. No longer can we just. Let's come over here. Let's come down here and rationalize this. Can I twist it? I can. All right. So I'm going to multiply square root 3 over square root 3. Now I can make that go in for part of P.
Can you really know?
Can I really?
Or part of it.
Yes.
Your part of it.
I think your calculator does this. I shouldn't have told you that. All right. So that's only 16 square root 3 over 3 is only one of the sides, but I need the whole perimeter. So what do I have to do to that?
Times 6.
Yes. All right. So this is how you're going to put this in your calculator.
32 square root 3.
Not really.
That's what I got.
32. I'll help you in a little while.
Oh, I did 16 over square root 3. Instead of 16 square
Yeah,
root
and then
3
it turned it into 32 square root 3?
It turned it into 32 square root 3. Yeah.
Oh, it should have turned it into 16 square root 3 over 3.
It did not.
We'll figure that out. No, we'll figure that out. All right, so...
Did you do it times 6?
Yeah.
Oh, when you multiply by 6. I'm sorry. Very likely that. Yes, my bad. Okay. So on your calculator, I would suggest that you do it this way. Everything in the numerator is going to be in yellow. The 1, the 8, the 16, the square root 3, and the 6 are all numerators.
Yeah.
The denominators will be in red, the 2 and the 3. Okay? Be careful when you put this in your calculator. All right? You could just do 1 divide 2 if you want to, and then divide 3 at the end to make sure you put in the fraction button. You could also do this. Your calculator, you could do, forget the 1, it doesn't really matter. 8 times 16 times 6. But be careful when you're doing your divides. This is divide 2 and divide 3 because they're both on the bottom. So there's a lot. You got to both, yes. Or you could multiply together in your head and say 6 and just divide 6.
Oh, okay. that's
Okay?
that's
All right?
easier.
Okay.
Time 8. And we have to keep it as...
Oh,
as
and the cool thing is wait, we could do this. This 6 and those 2 and 3s cancel. You wouldn't have to put that in your calculator at all.
What?
Mm.
Oh.
That 6 on the top cancels with the
Yeah.
2 and 3 on the bottom because they're both 6s. You can just put the 8 and the 16 in your calculator.
Oh. So I already even need to... Okay.
128 square root 3.
Okay, yeah. Yeah, okay. I think I got it, but I did it like a long way or something.
Okay.
And I'm gonna do
Is that what you get the same answer though? 128.
Yes.
What'd you get?
Oh no.
Let's see what we got here. So we're gonna do 128 square root 3.
Cool.
All right.
Drive my dad into it.
All right. We're ready for number 13.
These are nice enough to just give us the whole perimeter though.
All right. So this one gave you the length of the side. So we have the area of each figure. This time,
Yay!
how many sides does this have?
We get to round to the nearest tenth.
And we get to round to the nearest tenth now. You're going to tell me if you think that's better or not. There are 11 sides, I heard. Does anybody want to confirm that with me, please? 11 sides.
I don't really want to count. There's 11.
There's 11 sides. All right. So I am going to put a dot in the center and then make a triangle. Will that be an equilateral triangle?
No.
So you can't just find the area of one of them and then multiply by 11.
One.
What is the angle measure of that one?
Yeah. I don't know. 360
If
divided by
how many
11.
would there be if I did them all?
Divided by 11.
And then I can find just one of them, right? 360 divided by 11.
32.7.
Okay, so 32.7.
Wait, what?
360 divided by 11. Do you think that's going to come out evenly?
I personally, because I need more room, I am going to draw a large triangle that's representing the one there. And this is the 32.7. Do we have a right angle at all yet?
No.
We're going to have to draw one. Right down the center. Right down the center. I just replicated, but I like to write bigger.
No,
All right? Are you with me so far?
Yes.
almost. I just.
Yes.
How much is this little angle right there?
30. No,
16 or 30.
How much was the whole?
30. Well,
32.7.
oh,
So it's half.
32.7.
So it's half. What's half of 32.7?
Where we get 32.7?
Good question. Fantastic question. I'm glad you asked. Okay, so, you know,
Divided by 11.
yes, I could have drawn 11 of those triangles, right? And they're all equal, so I had to do.
Why?
So I divided 360 by 11, and I
That's
got.
smart questions.
32.7 divided by 2. Is that what we're going to do?
That's correct.
16.35.
16.35.
Okay, wait, oh no, it's exact. So we can't.
No, this is rounding. So but you're just
No, but
rounding
it's
your
exact.
answer.
Right now, we want to keep as many until the end. Okay.
It's exact. So we
All right. So I know this whole thing's 3. So that means that this little piece is 1.5 and that's 1.5. Are you with me so far?
Yeah.
All right. We are looking for the. What are we looking for? I
Wait
mean,
a minute. How do you?
sometimes you do all this work and then you forget what you've been trying to do.
Looking for some math.
Yeah, really though.
We're trying to find the area. This is a regular. This is not an equilateral triangle at all. So we're going to have to use the area of a regular polygon. What's the formula for that?
A equals 1/2 apothem times perimeter.
AP.
Which one of those do we know?
Nothing.
We know the
perimeter.
We know the perimeter is 3 times 11, right? All right.
30.
But we do not know. That's just 33. Do you want me to just write that? It'll be easier, wouldn't it?
Yeah.
Yeah.
Okay. All right. We don't know the apothem, but right here I have drawn the apothem, and I'm going to highlight it in red. This is the apothem. You know this angle is 16.35. You know this side of the triangle is 1.5. It is not a 30, 60, 90 triangle. It's not a 45, 45, 90 triangle. So what else do we use instead if it's not? Sine, cosine, or tangent. Okay, so we're looking for this one. This is
It's gonna be
adjacent
tangent.
and opposite.
Tangent, opposite over adjacent.
Okay, so I'm going to come down to the bottom. Tangent of 16.35.
What?
What?
What are you talking about?
I know, it's crazy.
16.
Equals what over what?
1.5.
I'm going to call this A, by the way.
No, 1? I got a 0.
1.5 over A.
Wait a minute.
Opposite
Where do we
over
get
two.
1.5?
good question. Thank you for asking that question, Amy. The whole thing is 3, so that half is 1.5. Okay? Okay, I'm glad you asked. All right, so tangent is opposite over adjacent, so it's 1.5 over the apothem.
Oh, I did that wrong.
When I did tangent, when I put that in my calculator, I got 0.29.
Yes. So what are we going to do to solve for A? Are we going to
Hold on. Oh, we're gonna opt.
we're going to
that number again.
flip it, right? So it'll be 1.5 divided by tangent 16.35. So
I'm not gonna put that.
Brett, I would do this the 1.5 first and then divide it by that little teeny number that you got in your calculator. But just divide it by tangent 16.35.
1.5.
2.006. What?
1.5 over.
Tangent.
16.
Is it 25 or 35?
35.
16.
35.
3.
Wait.
Maybe
I got an error.
What'd you do, Brett?
5.11. There's no units. Oh, there is units on this one. Careful, careful.
Don't do that. You're making me want to do that.
Wait, what?
You have to put
Yards.
Yards what? Is it yards? It's not just yards.
Yard square.
Yes, because we're doing area. That's one thing we haven't had to encounter until now.
Wait, no, but we haven't plugged that back into the
Stupid.
apothem thingy.
Why
That's
would
just the
you?
apothem.
That's just the
We're
apothem,
not
guys.
done
We're not
yet.
done yet.
Hey, what are you talking about?
That's just the
I'm gonna
apothem.
need a sticky note.
What are you talking about?
This is terrible.
I know.
Thank you.
All right, so this is just the apothem. So it's 1/2
7.7.
5.11 times 33.
So what now?
So that 511 is the apothem up here here. We have 1/2 5.11 times the 33.
I got 7.7 when I rounded. What?
Over. No.
Oh, wait, hold up. Never mind, my calculator got. Calculator did not do what I told you.
I got 84.315.
That's what I got.
33.
And it's just to the 10th.
Yes.
2. I got 84.3.
Yes.
And then we yard squared.
No.
Now it's yard squared. Good job, you guys.
No.
We're going to have to.
You.
We're going to have to. All right, 15.
I'm gonna write my memory verse like 5 times.
All right. Now I have a pentagon.
Question about the Bible verse. So when he said in
Here we go. What is this angle measure? What is that angle measure right there? How do we find it?
360 divided by 5.
360 divided by 5.
Wait a minute.
We're going to use area is 1/2 the apothem times the perimeter, and we don't have the apothem. How much is it?
72.
72. Now I'm going to make a larger replica of this.
Triangle.
This is what we're looking for, the apothem, which is right here. You said it was how much? 72 is the whole? How much is this little piece?
Beautiful. 36.
How much? That's 36. It's not quite a 30, 60, 90 triangle. Is everyone with me how I found that 36?
Yes.
I got one person who's with me.
I'm Megan.
Yeah.
How did we get the 72 for this one, Brett?
Wait a minute.
369.
No. How much is all the way around?
360.
Very good. And how many?
360 divided by 5.
Very good.
That in half.
Yes, very good. 360 divided by 5 and that in half. Okay, so I know that this is how long right here, this yellow piece that I'm going to be drawing right there. How long is that one?
1.
1.
Yeah.
All right. This piece is 1. I know this is 36. I'm looking for the apothem, and I have an opposite, and I'm looking for an adjacent.
So it's going to be tangent again.
Tangent again. Okay, so tangent 36 this time is better than 16.35.
This
Just
is
a little
true.
bit.
I'm going to call this A again because that is what it is. We have the opposite over adjacent. That's 1 over A. So A is going to just be 1 over tangent 36. Tell me what that A is when you've got it, please.
1 over.
1.4.
heard 1.4.
I got yes, 1.4.
That's what I got as well.
Okay, so we know that this is 1. We know this is 36.
You just shake.
Opposite and adjacent, so we determined it was going to be tangent. So tangent 36 is opposite over adjacent.
Oh, wait a minute. You just did the flippy thing. I thought it was a part
That's
of the
exactly
equation.
right. We just did the
Okay,
flippy thing.
never mind.
That's right.
B.
That is a B. We got to fix that one. Oh my.
What?
I've done
That
that
is
before
not
now.
a P.
I've honestly done that before now.
All right, I changed it. Fixed it. All right.
You've done that and just left it?
No.
Okay, I
Okay,
was about
so
to
we
say,
go.
that would make me so mad.
Depending on how bad my B looked at the time.
All right. The apothem is 1.4. What's the perimeter?
10.
Oh, wait, I
How'd you get 10?
2
2 times 5.
Very good. Because there's 5 sides and each of them worth 2.
That's 1.4.
And this time we get to put it all on your calculator.
Oh shoot, I gotta do my
Good.
Ooh.
thingy.
You got 7? Yeah. I got 7.
Centimeter squared, don't forget that.
7.
It'll be wrong.
Now, it's not really,
Ooh,
technically,
we
it's
got
not
an actual
exactly that.
number.
But, well, we rounded this 1.4, by the way. So,
Wait, what?
very close to 7.
Ugh. Yeah. It's 7.
Move over to 17. 17 says, find the area of each figure. Round to the nearest tenth. It gave you the perimeter. How does that help us now?
It basically doesn't do anything except. No, it doesn't do anything. We don't have any less steps because we have to do. We
You
have
don't
to
have to
figure
count the
out.
edges though.
We don't have to, yes, you do have to count the
You
edges.
do have to count
What?
the edges
Because we got to find this area.
Oh.
We got to find that angle.
You
Oh my
have
goodness.
no less steps. What's the point?
Because they want you to use your brain. So how many,
I'm using my calculator, not my brain. What are you talking
how many
about?
are there here? I think there's
use
7.
my brain.
Is it 7 or 11?
9.
9. I knew it was odd. Because odd ones have a point at the top instead of if they're flat on the bottom. All right,
That's
so
6.
9.
So
So
we're
what's
back to square
54
one.
divided by 9?
6.
6. So this is size is 6. What's this angle measure right here? How much is it all the way around?
360.
360.
Divided by
6.
9.
9. What is 360 divided by 9 is?
60.
Wait a minute.
Sorry.
Wait.
40.
Yes. I personally am going to replicate that down a little below again because I need a bigger one. I just can't work in that little teeny space. All right, we need this though. That's the apothem that we're looking for. I know that this is 40, but how much is that one?
20.
Yes.
20.
Okay, wait a minute.
How much is that piece right here?
3.
Yes. Good job.
I think I did something wrong.
Which part are you?
I don't know. I got lost. after we
Okay, good. No
started.
problem. Amy, I want you to tell me, did you get lost before the 40 or after the 40?
Like, both.
Okay, so we got the 40 by taking, we counted all the sides, and there are 9 of them.
Oh, that's what I did wrong. Okay.
Okay, and we took 360 divided by that 9 and got a 40. We
Yeah.
also took the 54 miles here and divided it by 9 so we can get the side of 6. Okay.
I just put the wrong number, and that's why we got lost.
All right, that now looks more like a 20, not like a 6. Okay, so here's a 20. How are we going to find this apothem right here? Tangent. We're going to say tangent 20 equals 3 over A, and then Amy's calling it the flippy dippy thing. We're going to do the flippy dippy thing. I love it. I love it. We're going to have A equals 3 over tangent 20. That 3 looks terrible. Brett always comments on my
Wait, no.
letters.
Wait.
That's not a letter, that's a number.
Oh.
Okay, see? Okay.
What?
3 over
I
tangent
always
20.
comment on her letters.
And that's a
not
number.
letter, that's a number.
All right, so what'd you get for the apothem?
8.3.
Hold up.
8.3, yeah.
What?
8.24.
Equals
So
8.3.
No, it doesn't.
322.
8.24
5, 8,
just makes
so
8.
it's 8.2.
Thank you.
All right.
To make sure everybody understands the full length of it.
The apothem, I heard was 8.2. Did we get a confirmation on that one? Not just one person?
Sure, yes.
All right. And the perimeter, Brett, we don't have to multiply by 9. We just know it right here. 54. Bless you.
So technically, it does save you.
No, it didn't, because we had to divide to get it, so it's the same.
So it's the
This
same
is
amount.
true.
It's the
but
same
you
amount.
just have to multiply.
We just last time we had to multiply. This time we have to divide. So it doesn't really matter. It's just they want you to be able to know the relationships between everything. Everything.
221.4.
22.4. I heard somebody confirm that.
22.1.4. Like
Yes.
221.
221.4. Yeah.
22.4. Is that what I heard?
220.
Oh, 200.
221.4.
Oh,
Miles squared.
221 point.
Yeah.
Only
yeah,
one
you have
decimal.
to write the rest of it.
Yes, ma'am.
And mine is
Yes.
exact.
I'm
Minus
hearing all
2.
these numbers. 4. Okay. Miles squared. All right. It's not.
Not-
Okay. Number 21
It's harder.
is similar. This one is review.
I give up.
This one is review, but we're going to be adding to this. Last week we started these.
Wait, what about 19?
All right. So what are we going to do to this
We're
one?
skipping it.
What are we going to do to this one?
Cross out the y's.
Yes, we're going to cross out the y's. Negative 8x and 3x turn into
Negative 5x.
negative 5x.
Negative 5x.
The 21 and 11, the negative 21 and 11.
Yeah.
Negative 10.
Divide by the negative 5.
X6 with 2.
X equals positive 2. We're done, right?
No.
No. We got to plug back in. We get to choose. In this world, everyone's telling you what to wear, where to go, when to sleep. I'm giving you a choice.
That's nice.
The top one or the bottom one?
I'm
Bottom?
maybe on the bottom.
Are we plugging it into the negative 8x or
3x.
to the 3x?
3x.
Okay, 3x. I like that one too. 3x minus y equals 11. I'm going to plug the 2 in for that x. So it'll be 6, right?
Yeah.
Move that over by subtracting. Negative y will equal 5, and y will equal.
Negative 5.
How do I write my answer?
X. Open parentheses 2, comma, negative 5.
Yes, as an ordered pair. This was what we did last week. I'm going to tell you that they won't always beautifully cancel like this. This was made to beautifully cancel, but sometimes you have to make them beautifully cancel. Let's move on.
Say what?
That's why I got stuck.
This comes from.
No, the x's, they're both negative, so they won't. So what we're going
I
to do,
see.
Brett, is we're going to make them opposite, okay? We're going to make them opposite as soon as my
Oh, yeah.
thing
I remember
catches
doing
up.
this.
Can we?
You get to decide, do you want to multiply a negative on the top or on the bottom, and it won't matter?
Top.
Why top?
Because the numbers are bigger, so there won't be negatives left over afterwards.
Fine.
Do you want to do it that way, Brett, or do you want to do the bottom? Because I'll do it your way, Brett.
We're gonna do the top.
Okay, let's do the top. All right. So that means that I'm going to multiply by a negative. That will become just plain old 2x. This one will become positive 6y. And this one will become positive 20. And I'm going to write it right underneath. Because then I don't have to rewrite that bottom one. And I don't like to write a lot. I like to do, I'm an efficiency expert. I like to do, just get things done. All right.
I just wrote mine on top.
So I'm going to, these two now will cancel. And this here becomes 2y. And this becomes negative,
Wait.
Eight.
positive 8.
Positive 8.
Why?
Wait a minute. Oh. Yeah, okay.
Okay.
And then 8.
I got
Yeah.
y is going
I
to
got
be
4.
4.
Yep.
Now I'm giving you even more choices. You can still plug them into either one of these. The bottom one's larger, not any larger. It's an all positive now. But I'm going to caution you not, well, it won't really matter. Plug it into anything you want. Because I was going to say, if you plug it into this one, it was wrong. If that one was wrong, then that would be wrong. So it won't
Wait.
matter. All right, so
What?
What you talking about?
don't worry about it. Okay. Which one are you going to plug it into?
Positive.
Positive? Positive. Okay. So 2x plus 6y equals 20. I'm going to plug that 4 into that y. That'll make it 24, correct?
Oh, wait a
Yeah.
minute. Yeah.
So 2x plus 24 equals 20.
So
Move that over.
2.
Yes, 2x will equal negative 4.
Mm-hmm.
No, it don't.
This is better than the
No.
shapes. It
This
is.
is so much better than the shapes.
Better than number 13. Number 13.
Oh, this is better than the shapes. What did you get for x, by the way?
Negative 2.
All right, so we write our answer as
Negative 2, comma 4.
yes.
Yeah.
All right. Let's move on now to number 25. All right. Now, I want you to look at these numbers now. They're not even the same now. I don't have anything that even looks like it can start canceling. So we're not only going to have to multiply by just a negative, but maybe a number, okay? We want them to cancel. So you have a choice here also. If I want the x's to cancel, I could make this one a negative 4 there by multiplying 4 to everything. Or
I know.
I could make the y's cancel by maybe making this be a positive 9 by multiplying by a 3 to everything. You have a choice.
Why? Do you know how bad I am at making decisions?
Maybe you should ask somebody to make
multiply
additions.
by a negative 3 so it comes up.
Yes,
negative?
yes.
I want to do that.
Okay, you want to
Okay, let's
multiply
do that.
this one by a negative 3.
Yes.
Okay,
Let's do
when you
that.
multiply, you have to multiply everything. You can't just multiply one thing. So this is going to become a positive 3x. That's going to become a positive 9y. And what is 12 times negative 3?
Negative 36.
Okay. And I just put it underneath the old one.
The Y's?
The y's now cancel. Okay? That's why we practiced last week with just having them cancel. So we're going to have 7x.
Equals negative
62.
I got
63.
63.
27.
Oh, yeah.
Yeah, 63. Right?
Divide by 7, and x is going to be
Negative 9.
negative 9. Now, again, you
Wait,
have the...
divide by 7.
Yes,
How did you get 7?
because I got 4x and 3x added to be 7x.
Oh, that adds because that's not. Okay, got it.
Okay? Okay. Good question. Thank you for asking. All right, so now you have 3 places to plug it in. This one that you redid is now larger numbers. I don't usually suggest that you put it in there, but you could. I would suggest you put it in the 2 originals. Which one do you want to plug it into?
The top.
I like the top one. Because it's already a negative 9, you're going to plug it in with that negative x. It's going to just cancel out that negative. Negative x minus 3y equals 12. This negative 9 is just going to be positive 9.
Wait.
Wait, do what?
But what's your question?
Why is that 3y? We plug it in to multiply, right?
It's an x here, so I plugged it into the x and left the y alone.
Oh, okay, got it.
Got it? Okay. Other questions? All right. So then I'm going to move that 9 over by subtracting. Negative 3y equals 3.
I went into the other place's space, but that's okay.
Yeah, that's what I got. It's negative 1.
Okay, so how do I write my answer?
Negative 9, comma, negative 1.
I agree.
New stuff in the next lesson?
Very little. Very little. Okay, here we go. I know, because we need to go. All right, so this time we can't just multiply one thing to make the other one. You couldn't multiply something by this 3 here on the bottom to make it equal 8. You can't multiply anything by 3 to make it 5. So this time, instead of just multiplying one of them, we have to multiply both of them, all right? So this is not too bad either, really. It really isn't. You need to just make a decision.
Giant long fractions.
No, actually, we won't have any fractions.
No fraction.
Except maybe at the answer at the end, but not when we're multiplying right now.
No, I mean, like, to make a fraction, like, you would have to, like if it's 2 fractions with denominators, you would have, like...
Yeah, you'd have to, if I wanted something that, yes, one of them would have to be a fraction, but we don't want fractions, so we're going to make sure we don't. So I'm going to choose for you right now.
15.
You want to make it 15? Okay, let's do it that way. I'll let you
That's
choose then,
the
since I said I was
small-
going to
yeah,
choose and you
it's
took
just
over,
the
Brett.
smallest.
Yeah, I think so
All right,
too.
that's what I'm going to do. I'm going to multiply the top one by...
Oh, this sucks.
Yes, it does.
The top one by 3 and the bottom one by 5, but be careful.
Wait, what
One
part
of them
is
has
this?
to be a negative.
One of them's going to have to be a negative.
Yeah.
And you get to choose again.
Let's do
Did I
the bottom
use
one.
too much space?
The bottom one?
Paper.
No, fine.
And I'm going to scoot over to do that. I like to do them right next door.
You want to use the
This is...
Torture. It's just plain.
Did I not give you enough
Like,
space in
I don't
there?
wanna do it. I'm just
Okay,
gonna-
I'm scooting over next to it over here. So I'm going to do my 3 times 8 and make that 24x right next door.
I don't have enough room. I wrote my other problem.
Make
That's
it
what I
really
did.
little. Minus 15y. Be careful. This is the part that most people mess up on, is after the equals, you forget to multiply by that 3. It is still a 90. Don't forget that. Then we're going to
Okay.
multiply a negative 5 over here to make that negative 15x.
Wait, yeah.
And positive 15y. And negative what?
45?
Yes.
Awesome.
No, it's not awesome.
I'm going to cancel out those 15s.
Wait a minute. Okay. Wait.
Or subtract out, however you want to call it. 24 minus 15
9x.
is 9x. Equals 90 minus 45 is.
45.
And that makes x equal to.
5.
Yeah.
All right, are we finished?
No.
No, of course not. You can now. You have 4 things to plug them into. I would not suggest these other ones because they're larger.
I'm going to do the bottom.
I'm gonna go to the bottom one.
Yeah, the 3x minus 3y. Okay, I'll do that one. 3x minus 3y equals 9. I'm going to plug this 5 in for that x to make it 15.
Wait a minute.
Oh, shoot.
Wait a minute.
Yeah.
Subtract
okay,
that 15 over. 9 minus 15 is negative what?
6.
Okay, I agree. Negative 3y equals negative 6. Y equals
2.
2.
Wait, no, that's not what I'm supposed to circle.
Yeah.
The answer is 2, 5.
Almost.
5, 2.
5,
5, 2. All right.
And order does matter here, correct?
That
Yeah.
is correct. That's why it's called an ordered pair, because the order does matter. Yes, it does. I'm going to talk about number 31, but I'm not going to do it.
29.
29, I mean. Okay, I'm going to talk about 29. This is substitution. This is nothing new. We've substituted this y in for that y and then solved last time, okay? But 31, which is coming up in a quick minute here, is what we're going to do now because it is new. 31 does not have a y equals or an x equals, but it's got a nice one that's close, okay? So we need to solve for that x so that we will have,
X equals negative 4.
we're going to move the 4y over there. Are you ready? We'll have x equals negative 4y because I subtracted to the other side. Now, anytime you see an x in the bottom equation, you will substitute in a negative 4y.
What?
In this bottom equation right here, it's 2x. In the place of that x, I'm going to substitute in a negative 4y. So it will look like this. 2 instead of the x, we'll put the negative 4y plus 7y equals negative 2. In this place, I will put the negative 4y. Are you with me, Brett?
Yeah.
Okay. So that will become negative 8y plus 7y equals negative 2. What is negative 8 plus 7?
Negative 1.
Negative 1.
Oh, they're both on the same.
Negative y
Yeah.
equals negative 2, so y equals how much?
2.
I'm finished, right?
No.
Now the cool thing about this one is substituting back in, you could choose all these, but I would only choose this one here.
Yeah.
Because you're ready. You just stick it in there, multiply by the negative 4, and you have x automatically. Put it into this one is nicer. We have x equals negative 4 times the 2 you just got, which makes it negative 8. And our answer is,
Negative 2, negative 8.
careful, try again. Put the x first.
Negative 8, 2.
Negative 8, positive 2.
Mm-hmm.
All right. Let's go to the next thing. The next thing's not going to be hard.
The next lesson.
All right, this is what we did in this lesson. You use sine, cosine, and tangent. You use the 45, 45, 90 triangles and the 30, 60, 90 triangles to help you with area. And we also did a little bit of that substitution and elimination. All right? Hope this has been helpful. Goodbye.
Hello?